Check, 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 check. We're good? All right. All right. Well, it's nice to see all your photons. It's been a long time since we've actually seen each other in person. I'm super excited to be back here. The very last meeting that we had was the first time that we met in this room, so this is the second time we've been at Farm Credit in a row. We don't like to have meetings with the same sponsor the same 2 months in a row, but this is an exception. So glad you're here. Super glad you're here. I'm excited to be here. I'm excited to stand next to Bruce and do this and have Brian up here with us and see all your smiling faces. So super exciting. We usually like to start our meetings off by asking for announcements. So as a community group, we'd love to get your input on the things that you're doing in the community and things that you know about that might be of interest to other people. So anybody have anything that they know or think might be interesting to other folks? A piece of technology you've been working with, or a podcast you listen to, or a conference that's coming up? Yeah, Nebraska Code's coming up in July, yep. Yeah, they're going to be in person as well. I think that's in Lincoln, right? Yeah. I think it's in the new facility. Oh, they have a new facility, okay. Yeah, that's exciting too. We get, I think that'll be probably the first conference in the area that's back in person. Yeah, thanks. Yeah. Was he just plugging Nebraska Code? Yep. Yeah, cool. Yeah. Yeah, good stuff.
Has anybody heard anything about HDC this
HDC.
year?
I think it is happening.
It is happening,
Yeah.
And it's going to be in person.
September, right?
Yeah.
September, I think.
So where?
I don't know where.
I don't know for sure, but I'm assuming back in La Vista.
That would be my guess.
Yep.
That's where they've always had it. So.
The morning code chapter is in September.
The what is?
The morning code. I want the morning code chapter.
Cool.
The same people from the
Oh, I'm going to say it wrong. Amegla or Amigla or those guys. Yeah.
Nebraska that.
Oh, is that what it is? No, that's Exarban. Exarban would, that's be an Exarban anyway.
Okay.
Good. Yeah, what else?
Some combination of Nebraska. We know that fits into it.
Just rearrange the letters enough. What else? Okay. Yeah, if you guys think of anything, send me an email. Love to hear from you guys. We have the Slack channel, so we'd love to see you guys on there. A bunch of people on there interact and have fun throughout the month, and then we come and meet together in person from now on, or hopefully we'll see if this holds. But so glad to be here, and glad to have Bruce from Arius, who provided all the food for us and some giveaways. This is a great welcome back. It looks like some fun stuff that you've got for us here. So I'm going to turn it over to you, and you can tell us all about Arius.
Okay.
Bruce is an awesome guy. My guy. So,
Thanks, Matt. Thanks. Yeah. That light's bright. I'll stand right here. I'm Bruce Peterson, Regional Manager for Arius Group IT, and I have a few teammates with me tonight. I have William and June and James here, so say hello and meet them if you can get a chance to do that. Appreciate it. We're really excited to be sponsoring. These sponsorships fill up quickly. They're chosen at the end of the year time frame and for the whole next year, and I think you guys sell out in about 5 minutes. So we're always grateful for the opportunity to sponsor, and it's kind of a little bit of wild card because you don't know by the time your month rolls around, especially in the middle of a pandemic, what you're going to be dealing with. But we are very, very blessed and thankful that we can meet here in person together, the first ones to do that and get back after a long time in hibernation. So I just wanted to take a few minutes to first of all just ask you guys, show of hands, familiar with Arius Group and Arius Group IT? Okay. I wanted to update you on something though that you might be less familiar with, and that is that Our previous parent company, CNA Industries, was acquired by Medical Solutions. And how many in the room have heard of Medical Solutions? Okay, good, fair number, good. So now this, very large combined company, over $1 billion in revenue and about 1,500 internal employees and about 8,000 contract employees across the country. It's really exciting for us at Arias Group because it's creating all types of new opportunities and new markets for us to serve. And so we have more opportunities and more clients than we ever have. And let me tell you, the demand is really, really ratcheting up out there. So, if you know of anybody that's in the job market, we'd appreciate you, sending them our way. You can have them contact me, and I'll get them in touch with the right people. But some really, really exciting opportunities going on. Let's see. I thought I'd just take a minute. I know we're running a little behind, so I won't take too long, but just to see if there's any questions out there about market conditions or, if you have any curiosities, because, my team is in constant contact with literally hundreds of different companies and what they're trying to do as far as hiring, how they're trying to do it. Are there any questions out there that you guys are curious about or want to get an answer to?
Are there any specific skill sets you guys are seeing a high demand for?
Well, I would definitely say the Microsoft suite and tech stack is probably by far in the highest demand out there. There's good demand across, a wide range of technology, but, Microsoft and everything, Microsoft is really at the top end of the spectrum. We have more orders coming in every day than we can even, think about trying to fill. So it's really hard. Yeah. Any other questions about what's going on out there or what we're seeing?
Do you feel like there's a kind of a mismatch between what people are looking for and who's available or what skills they have?
Yeah, there's a little bit of that. We've been seeing that for a number of years now, where companies have gotten pretty fixated on wanting a certain combination of skills and not really willing to deviate off of that. I would say we're entering into that phase now where they're starting to have to be more flexible, right? Because it's not a situation where they're just going to wait a month to find the perfect person with those ideal skill sets. They might have to wait a year if they were going to try to go for a certain mix. So they are becoming more flexible. I thought you guys might ask about going back to the office or not going back to the office or the hybrid or.
So, is the remote culture that expanded significantly? Or a lot of these, do you see a lot more remote opportunities now?
We definitely see a lot more remote opportunities. However, there's a lot of companies kind of straddling that whole decision process. They've been bringing people on for the last 6 or 8 months, and they've been allowing them to be fully remote while they bring them on. But there's always kind of, okay, when we get back into the office, though, we're going to want you to come to the office, and just a wide range of things. I think ultimately in the end, you're going to get a lot more remote, long-term, permanent, and hybrid scenarios for sure. I don't think we're ever going back to the mandatory you have to be in the office all the time.
So what about contract hires?
The thing about contract is that, in contract hire, they will allow you to work just about anywhere.
Phil gonna be on there, Phil probably.
Well,
Well, I mean, he's overloaded probably.
Phil's no longer he's moving the product.
All right. So thanks for being patient as we work through a few technical difficulties. We're trying to live stream this at the same time, and I think we have a little duct tape and baling wire and everything else involved in it. But I think it's stable and working. So, all right. So, topic for tonight is going to be WebAssembly. Although we're not going to be getting real deep into Blazor, we're actually going to be going beneath the covers of Blazor and looking at WebAssembly itself and kind of how that works. We do touch on Blazor a little bit, but it's mostly a core WebAssembly talk. And for the first slide, so just a couple of call outs here. I'm always a little nervous at the beginning of the talk, so I figure if I put a non-presentation slide in there, it gives me a chance to calm down and get going. So I figured I'd throw up 2 books on my reading list right now. On the left is actually a new book, and if you ever heard of Don't Panic Labs, Doug Durham and Chad Michael wrote this particular book. So I saw them tweet about it this past week and went ahead and added it to my reading list. And then the other one, the Hail Mary, if you remember the gentleman that the movie The Martian, the gentleman that wrote that book wrote this particular book, and it was just released just a couple of weeks ago. And where The Martian was dealing about getting someone back from Mars, this is kind of dealing with the sun actually dying. And just kind of an interesting book. If you're a fan of The Martian, I think you'll enjoy this book. I'm about halfway through it, so I don't know how it ends. I assume they turn the sun back on, otherwise it wouldn't be a very good book. So.
Did you read it in Spanish?
I did not. Is it? Oh, the little sticker is, okay. I did not. And I'm actually listening to the audiobook on that one, so I'm cheating on that one. But it's been a really good book. It's been one that I've been looking forward to, so. All right. So to kind of start off with, why not just use Blazor? You know, I mean, it's great technology from Microsoft. Why not just dive in there? Why spend the time learning about WebAssembly? The first example that comes to mind is the classic ASP versus ASP.NET. I kind of started out in that classic ASP world quite a while ago. But in there, you know, I was dealing with HTML and JavaScript, and then out came this ASP.NET thing, and it kind of promised you don't have to worry about the web. We have this web forms thing. You just build it, and it just works like the Windows Forms app. And I kind of watched as developers were struggling to move from that desktop model that they were using in Visual Basic to ASP.NET, and I just kind of saw that I had a pretty good advantage over them because I'd been working in the HTML and JavaScript and kind of the more classic ASP request response model. So that's one motivation for taking the time to learn about the underlying WebAssembly. I think the second one, and you kind of saw this from the title, where I titled the presentation not only web and not assembly. The path you end up on may not be the path you started out on. So I kind of started looking at WebAssembly with the idea of what will I be able to learn that I can apply to Blazor eventually. But what I learned is there's kind of this whole world of WebAssembly that doesn't even involve a browser. And so that's kind of an interesting, yeah. Okay, yeah. Teams is unmuted. Okay. So we're going to start by diving in, and we're going to actually start talking about, you know, what is WebAssembly. The first thing, it's a platform-independent VM, not unlike .NET. You know, with .NET we compile our code and it runs on this VM-like architecture. WebAssembly is really similar to that. And we kind of had this promise with .NET in the early days where there was this promise of you can write .NET once and you'll be able to run it anywhere. Didn't quite work out that way until recently with .NET Core and Mono, but I did kind of dig up, search for this on Stack Overflow, and I kind of came up with this interesting response here. You'll see they originally asked the question in 2009, so quite a while ago. That answer, answering with Mono, we're getting pretty close. With Silverlight, we're already there. And I don't think we're quite there with Silverlight. And then just to kind of put time into perspective here, you see the response down below there of the individuals complaining about the PowerPC Macs. And we've moved from PowerPC Macs to Intel Macs, and now we're moving over to M1 chip apps. So time marches on, I guess. WebAssembly is compute only. You don't have any access in the WebAssembly itself. You don't have any access to input, storage, network. WebAssembly is strictly compute only. Now there are ways that you can get access to those sorts of things. If you couldn't, it'd be a pretty useless technology. But in and of itself, WebAssembly doesn't have access to those items. I echoed. Okay. And it reminded me that I do too much because you echoed the right back at me. All right. So WebAssembly, they put that assembly name in there, but it really isn't anything like assembly. Assembly, text-based programming language, very platform specific. And you can see I found an example of some ARM assembly code in the box right up here, and a little example of some x86 assembly code. And you may not be able to read that in the back, but the thing to point out is even though they look really similar, they're different. The assembly that you write for ARM is very different than the assembly that you write for x86, and they won't work one on the other. So assembly is this very platform-specific stuff, where WebAssembly is actually a binary item. You compile your code down to WebAssembly, it's this binary item, and then that binary item is platform independent. As long as it can run on that VM, any place that VM can run on, WebAssembly can run on. And I do mean any place. So we'll look at this at the end. All right, so first demo. All right, just a word about the demos. I kind of have two sets of demos. I think we go through 7 demos throughout this. One group of them is running on Linux, and I'm actually using the Windows WSL tools for that, which is a great way to run if you have non-Windows workloads. It's a really great way. And then the other batch is .NET, but we're going to start off with some of the Linux-based ones. And the reason I kind of went with the Linux-based ones, even though the tools you can get them to work on Windows, they're a lot easier to get them to work on Linux. The ecosystem is just kind of built up around getting them to work on Linux. So the very first demo that I have here, and I'm going to So earlier I said WebAssembly is this binary target. However, as part of the spec, they also have this text-based format called WebAssembly text and WAT, W-A-T. And that's what we're looking at here. It's just basically a text-based representation that we're going to compile into a WebAssembly binary. This is kind of interesting to look at because you kind of dig right into the WebAssembly itself, how it works a little bit. So here, basically, what we're doing is we're creating a function, and it has a single method in there. I guess has add in there. Takes two parameters. Both of these parameters are int32s, and it returns an int32. And basically, what we're doing is we're calling that int32 add method, and then we're passing those two variables, those other two ints that we're passing in there. And basically, this is going to pop those two ints off the stack, add it, put the result back on the stack to return to the calling application. Now, so to compile this, there is a WebAssembly binary tools called Wabbit. I didn't make up the name, but people out there do call it Wabbit. Once you install the Wabbit tools, you get a whole suite of tools that you can run from your Linux command. And this one that we're going to look at here, it basically just will go ahead and compile that WAT file, that WAT file, into a WebAssembly binary. And it'll compile crazy quick, really tiny file. But we can see over on the left that add.wasm popped up. So we took our add.wat in, compiled it into WASM. Now, if I click on that WASM file, Visual Studio Code prompts me, this is a binary file. There's no point in a human looking at it. So we have our WASM file. Now, the next logical question is, how do I use that in a web application? So here we can kind of go through. Now, I don't actually interact with the actual user screen. I just basically console log to the debug console there. But all we're doing, again, a lot of these are async calls. This is really common in your JavaScript world. So we're first of all just going to straight up fetch that WASM file. Just go out, grab that WASM file. When that response comes back, we're just going to turn it into an array buffer, get our array of bytes, and it's just really simply WebAssembly.instantiate bytes. And when we run this in there, you'll actually see that every function that is exported in there, in our case we only have one, will show up under this adder_wasm.instance.exports object. And all that we do is we simply call that exports.add, pass in our two int32s, and take that result and just console log it. So pretty simple. I tried to, with a lot of the demos, I tried to boil them down to their basic essence, and I have huge demos, but so what I have here is just a really simple, very small HTTP server that points at this site directory. You do have to spin up some sort of web server. You can't just go to the HTML file. It won't run in that scenario. So you do have to spin up some sort of web server. All right. All right, there we got some. All right, so so we can get a good output. You can see the first console.log that we have is where we just logged out everything that's on that export object. And we can see, sure enough, on that export object is a function. We can see, we see we have a function down there. And then on the second one, we can see that we actually called into that WebAssembly function, said 1 + 1. We got the correct answer. WebAssembly knows how to add. So, first demo. All right, so one of the promises of WebAssembly is use whichever language you want. Now, there's a GitHub site out there where somebody's actually gone through the work of tracking all the different languages that implement WebAssembly, or that have a compile to target of WebAssembly. And you can see there's quite a few out there. There is a handful, as you'll look across those, that's unmaintained. They kind of have this little chicken in the egg style. If it's an egg, it's not very mature. If it's a chicken, it's a mature implementation of it. There is some interesting things to note. As you look through the list, you'll see a few dynamic languages. Like we see Python in there. We see, what's another dynamic language in here? PHP. So you see some dynamic languages, and the reason I call that out is WebAssembly itself, it expects it to be a statically typed language. It doesn't work too well if you're trying to compile a dynamically typed language into a statically typed language. So the way a lot of these dynamic languages actually work, and this is actually pretty cool, is like the Python, I know for sure. It basically, somebody went out there and in Go wrote a Python compiler or a Python interpreter, and then they compiled that to WebAssembly, and that is the Python WebAssembly there. Is so your Python code just runs in that interpreter in there. So you're not actually compiling your Python code to WebAssembly, it's just running in that interpreter. Something that I thought was kind of creative, kind of unique. And .NET, as we'll see later on, is something really similar to that. It's on WebAssembly. It's security first, denied by default, and that kind of comes from its roots in being a browser-based tool. You know, if you're going to go to some website, you don't want that code to have access to your file system. You don't want it to be able to do all sorts of weird stuff. That's why they kind of put this really strict sandbox around it. That's why WebAssembly doesn't have access to any I/O or anything like that, because they're really trying to maintain the integrity of that sandbox and that security model. We will see later on that there are tools and interfaces, standards and whatnot, that make it easier in working with the sandbox. But at least if you're working in the browser, you basically can pass those ints, ints, floats, signed floats, and function pointers around. That's really all that you can pass around. Stack-based, ints and floats only. So we talked about it passing ints and floats around. That's really not very useful to write an application. You know, at some point you're going to need to throw a string around, or you know, maybe even, you know, here's an object that we've serialized and we want to pass over to the WebAssembly. The way that this works in WebAssembly is they have this shared linear memory model, where if it's running in the browser, your JavaScript and your WebAssembly code have access to the shared memory, and basically your JavaScript can dump a string in there, pass it a pointer and a length over to your WebAssembly code, and that WebAssembly code can then read it off that shared memory. And so working with that linear memory is kind of a pain. We do have a demo that we'll be looking at here in a little bit, where we're actually kind of looking at an example that is manually managing that memory. But there are tools that make it easier. So the first one, that WebAssembly procedure call, that is just kind of a standard. It's really, the way it works is really simple. It basically, you serialize what you're trying to send over there, and it dumps it in that linear memory, and then the other side can pick it up. So it's a really simple process. It is kind of a pain to work with still, though, but it's kind of the best that we have today. In the future, there's WebAssembly interface types and WebAssembly reference types are both proposals for WebAssembly, and should make working with that linear memory, that shared memory, a lot easier. So, actually, I think one demo. Yeah, just the Rust strings. No, 2 demos. All right. All right, so I mentioned multiple languages. Rust is one of those languages. Rust was a language I originally think was developed by Mozilla, and it's in the world of assembly. Kind of all roads lead to Rust right now. Rust is kind of the king of web languages right now, and I think that's because it was developed at Mozilla at the same time as Mozilla was really active in WebAssembly and bringing up the spec, and so those two kind of grew up together. So if you're going to spend any time in that lower level WebAssembly, you're going to see some Rust in there. It's a unique language to look at. I don't understand it. I can kind of talk through this example a little bit, and that's about it. But basically what I have here is this example won't be running in the browser. I just thought this particular example just made more sense running as a console app. But we have a guest application, and that guest application will be compiled down into WebAssembly. And you'll see a couple of things here. First off, we're creating a buffer, and that buffer is going to be that shared linear memory that we're sharing between the guest and the host. We have this buffer pointer, and that's kind of like it sounds like. It's just it's wherever this buffer is set up at, it's going to return a pointer to that particular buffer. And then we have a set name, and you'll notice it doesn't return a name like you would if you were writing this in C# or something like that. You'd say set name, and then you pass a string name. But this is just passing an int32 length. And if we hop over to the host application, this one you'll see that we're going to reference the WASM that's compiled by that guest. We do a bunch of loading to load up that WASM file. And then we're going to call that get buffer pointer method. So here, get pointer buffer, we go ahead and call that function, and we're just going to print out what the address of that pointer is. And we're going to write omaha.net user group to memory starting at the pointer of that memory that we got from that guest. And then once we've written that, so we have a string, the guest doesn't know how long it is. So what we're passing in that int that we're passing over there is we're basically passing the length of the string that we wrote on here. Now in this case, it's since we called over since we got that pointer from the client side, we don't actually need to tell the client side what that memory pointer is because it's the one that gave it to us to begin with. So all we need to pass over is that length, and then we're going to do some work on that string over on the other side and pass it back. And then when we get that new string back, we're just going to echo out what the length of it is, and just straight up read it from memory and print it out to the console. So back to the guest one. I know I'm kind of jumping around here a little bit. Back to the guest one. When we call that set name, all that we're doing is we're taking the length of that off, and we're reading that much off the buffer, off that memory buffer, off that shared memory buffer, and we're just turning it into a string. And then we're just appending hello to the string that's passed in. And then writing that back out to the buffer and returning the length of the string that we wrote to that. So you can kind of already see there's a whole bunch of jumps going on here just to pass a simple string from one side to another. Fortunately, this is like the lowest level you'd ever have to do this. There are much, using that WA PC, much easier way to do it. In the future, we'll have that interface types and reference types that'll make this even easier. But I don't expect anybody would have to write here. There's already tools to do it at this level. I think it's just interesting to kind of know and understand that it is doing this shared memory dance. So I think I've already compiled the particular target in here. And so kind of in the interest of time, so we have memory guessed WASM. That's already compiled. I am just going to get my cheat. It's just cargo run. And so here the host is compiling, and then it's just going to straight up run. If you recall, that very first line, that one that starts with 105, is the address of the memory that we wrote the string to at the very beginning. In the very beginning, we wrote a 28th length string. Now there was a couple other hops back and forth that I didn't write, but we got the response, hello Omaha.net user group. And that was done just through dancing with that shared linear memory. In the second demo here, so the other demo, the other question that comes up quite a bit is how does the threading model work with WebAssembly? And the answer is it doesn't. Today WebAssembly doesn't have threading, and there are several reasons for that. One of the most obvious reasons, if you think of that shared linear memory that those two halves are sharing, as soon as you introduce threading into there, all of a sudden that shared memory gets a lot more difficult to manage. Because you can have one thread pulling stuff off, another thread putting stuff on. Really becomes complicated real quick. So there is no threading model with WebAssembly yet. No official one. Now, if you go out to Chrome, I think that they have adopted some of the early specs as part of Chrome. And they have some limited threading. You can basically, in your WebAssembly, my understanding it is, in your WebAssembly you can spawn almost like a background thread. But that's not part of spec yet. What is part of spec, and it's something that we have already today, is web workers. Now this is maybe another technology that you haven't used. I almost guarantee you've hit a website that uses web workers. Maybe you played with it some, but web workers is a JavaScript browser technology or technique that actually allows you to spin up a background thread in addition to that one thread that you get on the front end UI thread. You'll sometimes see it used, like an example would be if you have an offline sort of application and you want to do background syncs. I think Gmail actually uses it for background syncs. And that's how we're gonna add threading into our WebAssembly application. The WebAssembly isn't going to be actually doing any threading. It's just the background, the web. So basically, I have in my WASM, I have again, a really simple WebAssembly. This one is written, so last time we looked at TypeScript, this time we're actually looking at a language called AssemblyScript. And AssemblyScript is kind of a unique language. It's another language that's kind of growing up with WebAssembly. It uses TypeScript. So basically, think about TypeScript, but with a narrower set of types and statically typed. and some different types, you know, so like TypeScript, you have number. You don't have ints or floats, you just have number. Assembly script has ints. And you'll actually see this is a TypeScript file, but because it is, because Visual Studio Code thinks it's assembly or a TypeScript file, it's actually complaining because I'm using an Int32 and it says that ain't valid TypeScript. But it is valid assembly script. So really all that we're doing is we pass in a number and we just call a Fibonacci function on there. I just needed a function that does a lot of work. And what we're going to do is we have so the way that web workers work is you basically will point it to another JavaScript file and it just runs that JavaScript file in the background. Pretty simple. So we have this background worker file, and it is going to handle all of our WebAssembly work and just handle all of that. Our actual application here. So I do have a couple of examples in here that we'll see in the UI. In fact, let's. So the first one does not use background threads. So I'm trying to remember. There was numbers that I picked that made it take way too long. I think so. 20 comes back pretty quick, and it goes up quick. 30 comes back quick. All right, go 45. All right, so now we're at this stage where it passed on the work to WebAssembly. WebAssembly is doing its work, but you see the site is frozen because I'm hogging that single UI thread that JavaScript gets. So as long as it's doing that work, I can't interact with the site. You know, so horrible user experience. So this second one. We'll use that web worker, and I can actually go 50, and I don't get my answer, but you'll see the site is still interactive. I can still click around the site and do stuff. So, so that web worker is doing it. This is kind of the magic way that we do threads in assembly today, in WebAssembly today. And I should have chosen a smaller number because it goes up very rapidly. So, all right. All right. All right. So a little bit more about the sandbox. WebAssembly has no access to I/O operations, no network, no storage, that limited shared memory access. I guess one thing I didn't mention about the shared memory access is you actually have to request pages of it as you need it. So they don't just open up all the memory. You have to actually say, hey, I want 1 page of, and I can't remember how much is in a page, but you basically say, I need 1 page or I need 2 pages of memory. No console input, no DOM access. All of that, you have to pass your own functions to the WebAssembly to provide that I/O. Want to update a browser value in the browser with WebAssembly, you still have to go through a Java proxy. Now, with that WebAssembly reference types in the future, that may go away, where you actually can pass a reference to the DOM to the WebAssembly. That may eventually go away, but today you still have to have a little bit of JavaScript proxy running there to actually update the DOM for you. Relies on the host to provide all the I/O, single-threaded. Talked about that. The order on some of my slides isn't optimal. But hit demo 2 and 3. Okay, so what does this look like for .NET? .NET, the .NET framework, WASM approach, Blazor approach, is really similar to what we saw with Xamarin. As a matter of fact, that's why the Mono team was able to, that's why Blazor came out of that Mono project originally. And if you don't know, the way that Xamarin and Mono works on all those mobile devices is they basically ported the .NET runtime to that VM that .NET uses. They ported that to the mobile devices, so then you can just run your regular .NET code on top of that VM. And that's real similar to how Blazor works. How Blazor managed to do this is they didn't set it up to compile directly to a WASM target. They just ported the .NET runtime to WASM, and then they run your .NET code on there. Tomorrow, AOT. They've been kind of talking about this for quite a while in the Blazor community. AOT is ahead of time, and the idea is, as we'll look at an example here in Blazor in a second. Today you'll actually see if you reference like system.string or something like that, you'll actually see that assembly, that DLL, get sent to the client side. What AOT promises to do is basically rewrite all of that. So it'll basically do that pre-compile on your application so that you're just sending down the bits that your application needs, resulting in a smaller package going down to the browser. Microsoft actually just released the first beta of it about a week ago. So I didn't get a chance to dig into it. However, another company called Uno, they've been active in this Blazor space with Microsoft.NET products. They actually released their first Uno AOT compiler back in January. So they beat Microsoft to AOT by about 6 months, which I think was kind of interesting. And then kind of in that .NET area, I'd say .NET is all in on Blazor, not all in on WebAssembly. And we'll kind of talk about some of the challenges when we look at the Blazor demo here in a second. That might change. I don't know. I'm kind of hopeful that that'll change once AOT gets out there. And then there's other parts of Microsoft that, even though .NET I wouldn't say is all in on WebAssembly, there are other parts of Microsoft that are all in on it. And the Waggy and the Crustlet are two examples that kind of come in more into play later on, where Microsoft is really embracing the spec. Waggy is WebAssembly Gateway Interface, and it's either a proposed spec or an actual spec at this point. And then, and I think demo. And in the interest of time, I'm just going to do the first demo. The second demo might have kind of gotten obsoleted here. The first demo we're going to look at Blazor. The second demo was that other team that did AOT, that Uno. How I was going to look at how they did AOT, but with Microsoft having got theirs out, that might not be as important. You might see a shift back to Microsoft instead of them maintaining their own. So for the Blazor demo, I didn't do anything fancy. This is literally just file new Blazor project, and we're just going to run it and see what it looks like. All right. So Let me make sure the network tab is open. Clear the log. All right. And I have to do one step more than that. It pulls down a bunch. Well, it pulls down a bunch of stuff, and to avoid constantly pulling that down, it actually caches a lot of that on the browser. So that's why. Go clear that out, and we will reload this, and we'll look at what we have now. The first thing that should really kind of stand out is a bunch of DLLs. Now that's kind of odd to be sending in a browser, but that's kind of based on how Microsoft's strategy with this works. Is it sends, if we look through here, we'll see .NET WASM. I think there's also they have a bunch of JavaScript files that that go with it too. Not a bunch, but one or two. And this is kind of how we looked at manually wiring it up with just the browser tools. These two files here are doing a lot of that and kind of giving you the entry point into the .NET framework. But because we are running on that .NET VM, that .NET runtime, it's not just a simple matter of mount your item and call a function. It's a lot more involved, and that's why they have a lot of this additional JavaScript. That's also what makes it difficult for .NET right now to really participate in that bigger ecosystem, especially some of the stuff that we're going to look at in a couple of the upcoming slides. So I think it's kind of worthwhile just kind of pointing this out, that mechanism that it does. You can actually here's what I'm looking for. But any of these .dll ones, I mean, you could pull down and you could use your favorite .NET decompiler, and they would happily decompile. They are .NET DLLs at this point being sent to the browser. So it's just an interesting strategy that they're using in order to bring WASM, to bring Blazor to the browser. All right. And then the second demo that I had there was just going to be looking at that Uno platform, how they did AOT. All right, so kind of given what we've seen with WASM, kind of understanding how it works a little bit. These are some of the next three slides are kind of some questions that come to my mind as I learn through this. The comment that I've heard most often around WebAssembly is we want to use WebAssembly because it's faster. And maybe, but keep in mind you're still going through that JavaScript layer to write all your DOM elements. You're still dealing with the DOM. If you've worked with me and had a website that we were troubleshooting, you'll know eventually I reach for this particular snippet, and basically this is just a really simple snippet that you can drop into any Chrome inspector, and it will tell you how many DOM nodes you have. So on this particular page, I have 44 DOM nodes, and I think on the slide I'll normally say absolutely no more than 10K, and 10K is too many. So like a lot of times when somebody comes to me and says my website's slow, it's just feeling sluggish, we run this little snippet and you look at it and you have 20,000 DOM nodes. Of course your site's slow. WebAssembly isn't going to help with that at all. That's either implement virtual scrolling if you have a big data grid, or maybe go back to your product owner and say you can't put everything on one screen. So So then the next thing that kind of comes to mind is your site slow because you're doing a bunch of computationally expensive work in the browser? I think the first question to ask there is, could that be moved to the server? Maybe it is something. I know you're seeing even video inputs now being done through WebAssembly in the browser. That may be a valid use case in order to show that real-time immediate feedback. But I do think if you're dealing with a slow website and it's got computationally expensive stuff, is there a way that you can move that back to the server before you make that jump to WebAssembly? Not that I'm saying anything's wrong with WebAssembly. I'm just saying it's not a magic fix-all bullet for your performance issues. The other items, and I think there's some real validity with these sorts of things. Is there room for code reuse with WebAssembly? Validation logic. Can I set it up so that I write my validators once on the server and then I ship those same validators to the client side, whether using Blazor or something else, ship those same validators to the client side so that you're getting immediate validation, but you're not worrying about 2 code paths to maintain. I think that's a really valid use case for WebAssembly. I think there's also some calculations that could be done. I don't know, if you're having the user enter a whole bunch of figures and you're going to send it back to the server to calculate the actual real value, great, but maybe you can ship that same calculation logic to the browser in a WebAssembly and calculate the numbers there to give the user immediate feedback so that they're not waiting for that round trip. And again, you can do that with, that's one of the prime use cases for tools like Blazor. So Blazor or any of these other WebAssembly tools. And then I guess the other thing that was kind of interesting, WASM for browser, interesting usage. There's one project for FFmpeg. It's actually an open source video encoder tool. Somebody went and ported that to WebAssembly, and they didn't actually have to port it to WebAssembly. They just recompiled it with a compile target to WebAssembly, and I guess they probably did have some porting work in order to wire up that I/O stuff, but they didn't have to go and rewrite all of FFmpeg. There's a group. I'm not going to be able to run it in the browser because it takes forever to download all the files, but somebody went and did the same treatment with Doom 3. And so it's actually running in, if you had it running, it'd be running WebAssembly behind the scenes, playing Doom 3 right in your browser. And then of course the different frameworks, so you have Blazor. Blazor by far, I think just due to the work that Microsoft has done with it, Blazor by far is the most popular WebAssembly framework today. But you also have U in Rust, ASDOM in C++, Vugu for Go. Those are kind of, just from what I've seen, those are kind of the top 4 WebAssembly frameworks. And by that I'm talking about things that replace tools like Angular or React, frameworks that you can use to build an actual application as opposed to just run a bit of code sort of thing. As we've gone through these examples, yeah. Yes. Yes. And we briefly touched on this slide. I think, this is a list of all the languages out there. And I'll just repeat it for Matt. I know I said it early, but I'll repeat it for Matt. He was working on the microphones and stuff. A lot of these dynamic languages kind of have an interesting approach where they actually compile the interpreter to WebAssembly, and then Python will, Python, for example, will run in that interpreter in the browser. So yes, lots of languages, lots of interesting stuff. Nope. All right, so So we. Sorry to everybody listening on the stream. All right. So what we've talked now is a lot of browser usage. And that's interesting. That's where I started out with this WebAssembly, is really kind of, what does it look like in the browser? But as we recall, back to like my second or third slide where I said the path you end up on may not be the one you planned on taking, I think the thing that's interested me most is all the non-browser use cases. Now that's kind of weird to think about. We think WebAssembly is a browser tool, but it's got a real rich ecosystem outside of the browser, and we're going to look at a few of those cases. This particular slide, it's not my slide. This was actually presented by a gentleman a few months ago at a big cloud native conference, and he was really making the argument, or the point that we originally started running on bare metal PCs. So on your left side, we were building our applications. We were worrying about setting up the computers, installing the operating systems on there. I know, even though in a lot of my cases I wasn't directly maintaining it, I know throughout my early career I spent time in the data center, even though I was just a developer. Not just a developer. I was a developer, but I still spent time in the data center, and I pulled machines out of racks and stuff because we had those physical computers. Then the next step was cloud, where all of a sudden you didn't have to worry about the computer. Amazon or Microsoft, they took care of that. They typically had some sort of hypervisor running on it to provide a VM environment. And then, depending on what your cloud model was, sometimes you were worrying about the operating system, sometimes you weren't, but you were building on there. So we moved up the stack. Now with things like Kubernetes, we've moved up a little bit further. So now you typically have a computer, typically have some sort of hypervisor, and then you'll have Kubernetes, the Docker kernel, running on top of there. And you're building these Docker images, so your world shrunk a little bit more. Shrunk, but it also got a lot more complicated, didn't it? And so the promise is, or a potential promise is, WebAssembly can go one level above the Docker. So one of the big purposes of having Docker is it's a sandbox. Well, WebAssembly is a sandbox. And I would argue that as it was designed, WebAssembly is a much better, stronger, more secure sandbox than Docker is. You can find plenty of exploits that'll get you out of the Docker sandbox. But since WebAssembly was designed from the ground up to be that secure sandbox, you end up with a lot fewer of those exploits. And instead of building Docker images, which can take up a lot of space and take quite a bit of time to build and move around, WebAssembly oftentimes you're throwing around a compiled WebAssembly that is a few K. So this is kind of looking at moving up there. Another interesting thing that's kind of related to this slide, one of the original creators of Docker has actually come out and said if WebAssembly existed when he created Docker, he wouldn't have created Docker. There'd be no need for Docker. He just would have used WebAssembly. So that's interesting. So what does this non-browser WebAssembly world look like? The first tool that we're going to look at real quick is a tool called WasmTime. And WasmTime has been ported to several different platforms. And somebody also went out and ported it to .NET. So, Visual Studio loads up here. There we go. All right. So what we have here is a console application. Our very first example, we looked at that adder WebAssembly code, that WAT. This is the exact same code, just text-based WAT file. I kind of kept it as that text-based format just because it was easier to mess around with. I didn't have to run out and compile a WebAssembly. I could just mess with it right here in line. But I could do everything that I'm going to show here against an actual WASM file as opposed to a WAT file. And we have this. So we've added a reference to a tool called WASM Time. Now it is preview. Don't run out and try and do this on your production application and say Brian said it was okay. But using that WASM Time, we're going to create an engine. We then basically load up a module from that adder WAT, just that straight up text file that we had. We'll create a new host, and then we're going to use that dynamic keyword that you might have seen occasionally in C#. We're going to create a new instance of that host, and that host exposes that add method, so we're able to call that and just add on to there. And if put that on there so it makes sure it doesn't close it right away. So we're just going to run this real quick, and we get our answer there. So this seems like a perfect or a simplistic example, but immediately where my mind goes to with something like this is a plug-in sort of model. I can kind of see a scenario where you have your application running, and maybe you want to allow end users to add some custom code and run in a secure model on your server. You could conceivably put something together like this that runs it in that nice secure WebAssembly sandbox. And as a matter of fact, we'll point out a couple of companies that have done exactly that, companies you've probably heard of. So the next example, kind of still in that mindset of running it outside of the browser. This WASM Cloud project. It's a new project. It was actually just started this year, and it was formed by taking two other projects and taking the work that they were doing and joining forces, and they've done some really good work. But basically, the thing that I picture in my mind as I was going through this is it's basically Kubernetes cluster for WASM. If you played with Dapper in the .NET world, if you had a chance to play with that Dapper, not the SQL tool, but the microservices tool that Microsoft released a couple of years ago. Yes, that's it. This WASM Cloud has a really similar kind of, they call it sidecar model. This is really similar, where we'll hop over and take a look at some code. It's easier to explain with the code instead of just. So what we're doing here is this is our this index.ts file that we're looking at. This is our actor, and kind of like Dapper is kind of real big into the actor model. This WASM Cloud tool is real big into the actor model. This, we're writing an actor, and we're connecting it to these capability providers. So even though we can see we tie it to this actor HTTP server, that's an abstraction. we're not actually wiring up an HTTP server in this, or we're not actually creating an HTTP server in this actor. That WASM Cloud runtime is actually going to be doing the web server part and just forwarding those requests into this abstraction that we're going to then respond to from here. This particular code isn't mine. I'll show you where I shamelessly stole this code from in a bit. But basically, there's quite a bit of boilerplate to it, unfortunately. And we're, just to note, we're looking at assembly script again. We have this WAPC init that's basically registering health checks, just some boilerplate code. Health check is boilerplate code again. And handle request is where we do our actual work. So whether we were going to be wiring it up to this HTTP module, we would still ingest it with that handle request. And really all that we're doing is we're looking at the query string that's coming up. We're splitting it to 2 numbers. And then we're just looking at the path, so if it's slash, we're going to try and add those 2 numbers. If it's slash subtract, we're going to try and subtract those 2 numbers and on down the line. And there's a few steps in making this. So I actually, since I'm running on a Linux machine, I was able to go out and actually set up a make file. So that made it a little bit easier to work with, all these steps. Building is nothing terribly fancy, but the publishing, this is kind of the equivalent if we were looking at a Kubernetes scenario. This would be where we package up our Docker image and we publish it up to the registry. As a matter of fact, it is going to publish it to a Docker registry, an OCI registry. So I actually, using Docker, I spun up an OCI registry that I can then publish this to. And so during this publish phase, we're gonna just take that, package it up. Again, it's not a full Docker image. We're not dealing with a big heavy thing. We're just a nice small WASM file. Going to publish it up to there, and then when we do this WASM Cloud, it's going to read this manifest file, and in that manifest file, we reference our calculator actor that we have. So we've said, in this system that we're spinning up, we have a calculator actor that we built. We need the HTTP server capabilities provider. So I didn't write this HTTP server or this HTTP server. I just need that capability provider. I need the capabilities that it provides me. And then I will actually link these two down here. So this VAG hash is the actual signature of that capabilities provider. This one is the signature of mine, and you do have to do a cryptographic signature on there. So there is keys involved in here. Won't dig into there, but that's just kind of in keeping with that security first mindset. But if I go. I'm in the wrong directory. Okay. So it did a couple of things. I think we had 3 command steps. First step is we went ahead and we signed that WASM file that we created. And then we called this inspect command to actually see the module. So this is the module that we just signed. Account is when I set up this cloud instance. That's me. Module is this particular calculator module this calculator actor that we just created.
We had 3 commands. First step is we went ahead and signed
Echo.
that WASM file that we created. And then we called this inspect command to actually see the module. So this is the module that we just signed. Account is when I
module, this particular calculator.
Man, I say a lot. Oh, here. Here, I can do it this way. There. I muted my speakers, so I don't think that'll happen again. We've got so much duct tape together, even though I muted my speakers, it might still happen. All right, so we went ahead and signed this. This is the calculator module. You can see as part of that signature process, you can actually say this expires. So you can actually say, you know, this is only going to be valid to run on my server for the next 30 days or whatever. And then we push it up to that that OCI, that registry, that Docker registry. And again, even though we're pushing to a Docker registry, we're pushing something tiny versus a lot of times when you're pushing your Docker image, it can be a good size. So then we can do run and address already in use. All right, so we can run it. Now, what this runtime is doing, so I'm running it in kind of a single host mode. It can be run across multiple computers, you know, kind of the same way you would do with a Kubernetes cluster. But this is when I ran this, it went out to that registry, pulled down my package. It wired up internally, because I had that manifest file, it wired up my package to that HTTP server. And now I can go, I'm actually going to do it with curl. And I can't just do a normal curl because my actor, I haven't quite figured out why, but it doesn't actually send the response down with the correct header, so it thinks it's a binary response even though it isn't. So I have that. We can see it. It went out. I have some debug text in there, but it went out, called that adder function, returned that result to me, and you can hopefully you can kind of picture, even though I have just a single actor in here, you can kind of picture how I could have a network of microservices all kind of communicating with each other, all written in WASM, different languages, you know, whatever. So, all right. And then the final demo, so we weren't able to get my phone. I had this whole setup with my phone where I'd be able to actually show you a close-up of this. But earlier this year, Raspberry Pi organization released the Pi Pico, and this is a little Pi Pico device. And somebody came out with a little Pico display hat. It's a little, just probably plug it in here. Pico display, so you can kind of see it lighting up there. And I know you can't see what's on the display, but what somebody did is this gentleman, he's kind of a glutton for punishment, because what he's gone is he's written in that WAT language. He's written a whole bunch of demos, and one of them that he wrote was Dino. So he wrote Dino WAT, and maybe you know what I'm talking about when I say Dino, but I'll show you in a minute. He went and wrote this little game, all in WAT, and published it out so we can see it. It's running in a browser. That's the wrong one. Dino. All right. So this is Dino. It's built into Chrome. It's a little Easter egg built into Chrome. He went out and recreated this in that WAT language. And then when the Raspberry Pi Pico device came out, another individual, he picked up that same WAT file, didn't have to change that, didn't have to rebuild that game logic. He did have to go in and put a few hooks around it, but he ported it to this, and you have the exact same WAT browser running here and here. And so that's kind of just showing you that, big laptop, little teeny memory constrained, tiny device that was only released 6 months ago, running the exact same code because of WebAssembly. So I thought that was kind of interesting. And that, okay, so then, is anybody actually using this non-web WASM stuff? Both of these, so Cloudflare Workers is a WebAssembly, they have a WebAssembly mechanism for doing this. They also have non-WebAssembly ways to do this, but they've also released this WebAssembly way where you can actually think almost like Azure Functions, but running on their CDN edge. So you actually can write these WebAssembly modules that then get pushed out to the edge. And let's say, an example might be you upload an image and you want it to resize the image. Well, it can just send that one image out, and then on the edge, on each of those edges, it can regenerate all the different thumbnail sizes you need and stuff like that, and you don't have to send 50 different thumbnails around. You just send the one base image around. And that's all, that you can write all that with WebAssembly. The next one is Shopify. Now, I think this is a really interesting use case. They're actually using WebAssembly on the server, and they have a plugin model where anybody here, if we have an idea that we want to create an extension that runs to the Shopify carts that their customers can build their e-commerce sites on, you can actually go out, write a WebAssembly module, and then that customer can then pull in that WebAssembly module into their checkout, to their shopping experience process. So let's say an example that comes to mind is let's say you're UPS and you want to allow Shopify customers to be able to calculate shipping costs or something like that. You could create a little WebAssembly calculator that will run as part of on Shopify servers as part of those customers' checkout experience. So that's just an example where they're letting anybody run code on their servers, and I think that's just kind of a unique, interesting use case for it. And then the final one is Microsoft Flight Simulator came out, I think, late last year, and they have a couple of extensibility models in there, but one of them is WebAssembly. Now they don't support any language right now. They only have bindings and whatnot for C, or detailed instructions for C. But if you wanted to, you could probably figure out how to get any language to work. But yeah, you can write your extension to Microsoft Flight Simulator, and it's a tool that already there's a lot of extensions out. People building custom airplanes and custom cockpit controls and stuff like that. And those can be written in WebAssembly, running outside of the browser in game. And so just another interesting use case for WebAssembly outside of the browser that I came across. So that's my presentation. Is there any questions? Oh, so you're asking, you're asking, we used to have in the olden days before Chrome ruled all, we had kind of these browser wars where things worked one way on Internet Explorer, but they worked a different way on Firefox and a different way on Safari. And well, so I think right off the bat there's a real strong standard right now around WebAssembly. So it's been an approved and adopted standard. So that's what makes it different from Silverlight. Where Silverlight was Microsoft kind of going out and building their own thing, and that left plenty of room for Steve Jobs to go in there and shut down Silverlight. This is actually a standard, and browsers have basically said, yeah, we're going to buy into that standard. And I believe there's also test suites and stuff around there, and I think it is a good sign that we can take WebAssembly that was written for the browser, like that Dino game, and that was written before this device was even released, and it came out and was able to port it to this device without changing the WebAssembly, just picking up that exact same way. So that's kind of testament to the standards working, and hopefully it'll continue to work as we go into the future, and we won't have this fragmented environment. So I think there's also enough people that are aware of the bad old days in the browser wars, and maybe that's incentive to stick to the standard and not go off cowboy. So good question. Any others?
What was the name of the sidecar?
WASM Cloud. And thank you for asking me. There is I did not want to go to there, but here. Okay. So this is that sidecar, that Kubernetes-like thing, or that Dapper-like thing. There is a couple of learning resources. So if you just go out to wasmcloud.com, and then on this Try Now, there's 2 items on here. So the first one that I'll point out is this WASM Cloud Class Online. This is it's a free class. You can enroll into it. I think once you enroll in it, you have 6 weeks worth of access to it. I think there are 6 modules, and each module probably took me about 2 hours to go through. But it really starts you at the very bottom of WebAssembly, handwriting WAT files, and going up through to eventually building out a WASM Cloud cluster. So if I basically did it over lunches for a couple of weeks. Great way to kind of get your feet wet if you want to learn about WASM Cloud, or WASM and WASM Cloud. The other thing that they have a link on there is, I don't know if y'all have heard of Kata Coda. It's kind of a slick little platform. I'm still logged in. So what this is, and it can be a little flaky starting up, but when it starts up, behind the scenes it's spinning up a VM. And that VM is basically all set up, synced up to the course that it's going to take me through. And it loads a Visual Studio Code in here. And so you can kind of actually follow through and do the work that it's talking about in here in this virtual environment. So you don't have to worry about setting up a bunch of stuff on your system. And this actually takes you through, there's 2 modules to it. One takes you through kind of the administration and setting up of WASM Cloud. And then the other module takes you through programming your first actor. And the actor that we looked at with that adder is directly from this course.
So I noticed that they had code signing and stuff kind of built into that, but did you run into any code signing related stuff in some of the other levels?
The other levels didn't have code signing. So WebAssembly itself doesn't have code signing. That's just kind of an extra that's been tacked on for WASM Cloud as part of their security model. Now, we didn't show it too much, but there is a WebAssembly system interface spec. It's actually approved and out there right now. You'll see it called WASI, WASI, and that kind of specifies how you can have standardized interfaces for connecting to things like I/O and storage and stuff like that. And when you use that, it's actually, again, it's denied by default. So you either have to have a file alongside of it that says this WASM file has access to this file on my disk. So you don't have code signing, but you do have that very strict permission model that you have to grant it access to either any sorts of I/O in order to work. So, and it'd be a system administrator that would be doing that granting, not, more system administrator hat as opposed to developer hat, I guess. So, any other questions? All right. Well, I enjoyed getting back. First time back. Was happy to present. So, I think we have some giveaways, don't we, Matt? All right.
Quite a few, actually. Bruce is going to come up and help me figure out what it is we have to give away.
Did you figure out how we're doing winner picker?
This is going to be fun, too.
Okay.
It might fun. It might be a little bit convoluted.
Well, since the picker's not working, I just coded up a little app here on my phone.
Did you use WebAssembly?
I think we got a plan here, though. So you know what all the, when I call a number, who it represents, right? Because you counted the room and.
I think we have 22 people, so I'm gonna count to.
If you hear your social security number, you want.
I'm
Okay.
gonna count the room real quick, and when I point at you, that's your number. All right. 1, 2, 3, 4, 5, 6, 7. 7, 8, 9, 10, 10, Jim, you're 11, 12, 13, 14, and then going back. You guys all go. Two here on the, okay.
No.
Okay, so, gentlemen, you have flat there, 15? That's 15? 16? And then Duval, 17, and the guy next to Duval is 18.
So
And John is 19.
I remember this exercise from the first day of basic training. Somebody's going to forget their number. I guarantee. And we're all going to have to do push-ups.
Well, I'm not reprogramming my app, so there's 3 that won't count if I count.
Okay, so I think we counted 22 to start with.
Yeah,
We have
yeah,
people that
so 19.
left.
Okay, so I think the way we're going to do this, and June, you're going to help me a little bit. We've got a variety of stuff. You never know what's in the prize vault after 1 year of, being in a pandemic. So what I do know is back there is there are some shirts, both T-shirts and golf shirts. There's not a wide variety of sizes, so that might come into play depending on what you choose. So I'm going to just let you pick. And then there is a watch from Movement. I don't know if you're familiar with that brand or not, but they're pretty nice. And then there is a 1 hour golf lesson with Golf Tech package that's back there. So I'm not going to just say who gets what. I'm going to let you pick based on your interests, okay? So let's see here.
I'm playing the Dino game.
Are you? Okay. The first, did you say there's 19? Okay.
19.
Okay.
Oh, 20, sorry. I think we had 20. We had 22.
Is it 20? Because 20 came up first.
20 came up first?
Yep.
Okay, I think that's, he doesn't need it.
Okay, he's forfeiting.
Yeah.
Okay, the next number that came up was 17. Who's 17? So June can help you pick something out. While they're doing that, I'll get another number here. Number 2. So you can head back there and pick something out. Number 4. All right. Number 9. Okay, we better halt for just a second and see what's left after they kind of
Yeah.
pick through the stuff.
So while we wait, is anybody going to go out and build something in WebAssembly? Anybody have ideas on what they want to do at work or at home or with WebAssembly?
Blazor counts too.
Yeah. I've been very, very excited about WebAssembly ever since it came out because, to be honest, I don't like JavaScript. So I think that it provides a nice alternative.
Is it mostly for like just number crunching then?
I think you can interact with people.
I mean, the core WebAssembly is just number crunching, but it's, you know, it has ways that you can work with strings and stuff. And honestly, the languages that you're writing, you don't have to worry about that. We were looking at lower level stuff. So like if you're gonna write something with .NET or whatever, you don't have to worry about special ways to handle strings. The compiler process handles it. So
People will build abstractions.
yeah.
Hey, June, do we have enough variety to pick one more number back there, or are we kind of limited on?
The golf shirt and the t-shirt.
Okay, we're going to pick one more number then. All right. It's right here. Number 7. All right. Worked out well.
Yeah.
When it came back.
You got some high numbers, some low numbers here in the middle, sorry.
Okay, well, thanks for coming out tonight. There's a little bit more food back there, so if you want to grab a box or take some with you, take a
Maybe the lunch container that you
yeah, maybe use the lunch container. Yeah, it'll clean out, wash out easy. So throw some stuff in there, and yeah, please do. I want to make sure it gets consumed. So,
Great.
all right, thanks.
Yeah. So. Yeah. Thanks, Bruce. I think we're gonna be back here again next month. We'll do the exact same thing, different sponsors, same host. So we'll get together. Thanks, Bruce, for the giveaways and for helping us get back to person and all that. So if you guys haven't had a chance to talk to Bruce, definitely do that. Yeah.
Yeah, you post his presentation on the website.
It's so that.